Good evening. How are you? I am Professor Oliver N. Maitera. I will be taking you in CHM 205 Inorganic Chemistry. The course Chem 205 has a prerequisite. The prerequisite is Chem 101 General Chemistry, which I expect if you are able to go through that course, you should have been able to handle the periodic table, how elements are arranged on the periodic table, the vertical column, which is the period, which is the group, and the horizontal column, which is the period. I also expect that you have looked at the S block elements. That is the alkali elements and the alkali elements. I also expect that being able to understand the periodicity of the properties of the S block elements. In this class, Chem 205, we'll be looking at the P block elements. That means group 14, 15, 16, and 17. Or otherwise, in some books, you see group 4, 5, 6, and 7. For this very particular class we have this evening, we'll be looking at group 4 or group 14. Group 4, which is the carbon group. It comprises of these elements: carbon, silicon, germanium, tin, and lead. Each of these elements have electrons going into their p orbitals, hence the name p block elements. Also, one noticeable character we will observe in this group is that this is when there is now a transition from non-metallic character to metallic character. Because in this group, carbon and silicon are non-metals, while germanium is a metalloid. Metalloid in the sense that it has properties that falls between the metals and the non-metals. Then you have the weakly electropositive metals like tin and lead. Now, if we look at the group, like we said earlier, you have carbon, silicon, germanium, tin, and lead. As usual, we have been told that there is a gradual increase in electropositivity as you go down the group. the group 4 elements or group 14 elements are not an exception. Carbon and silicon are non-metals. Germanium is metalloid, and tin and lead are metals. Carbon, being the first member in the group, has peculiar properties or exceptional properties, or what in inorganic chemistry we call anomalous behavior and abnormal behavior. Abnormal in the sense that it differs remarkably with other members of the group. Carbon has 2 allotropes, that is diamond and graphite. And it is lustrous in nature. While graphite can be able to conduct electricity, diamond cannot, because it is hard in nature and movement of electrons is restricted. Tin and lead are amphoteric, or they form amphoteric oxides. Amphoterism is a property that is exhibited by some elements or their oxides, which falls between acidic and basic nature. So in some circumstances, they can act as acids. Under some other circumstances, they can act as bases. Hence the amphoteric behavior. They also form volatile chlorides. Their chlorides are volatile. Now, for this very particular course, there are main objectives we are expected to attain at the end of this class. One, we'll look at the occurrence of these elements, their extraction and uses. 2, out of those properties, we are going to look at allotropy, that is the different forms in which these elements exist. We'll be comparing their properties and also try to explain what is meant by catenation. So occurrence and extraction. Carbon is one of the elements that is common in nature. It is found in all living things. And because of most of the compounds it forms with hydrogen and carbon and itself, as a result of that, carbon itself has a particular branch of chemistry that is dedicated to it. That is the organic chemistry. The organic chemistry. Hello, are you with me? Fatima?
Yes, sir.
You are with me?
Good evening, sir.
Good evening, how are you?
Yes, sir, I'm with you, sir.
I've started the class for some.
I'm fine, sir.
You are only joining. Hello?
Yes, I'm quite busy. That is the reason why. I'm sorry, sir.
And you seem to be the only person that has joined. I actually started the class for quite some time now. But for your sake, let me just try to brush through what I have said so far.
Okay. All right, sir.
So please listen to me attentively because I'm going to ask you some questions at the end of the day.
Okay, sir.
I try to let you know that Chem 205 inorganic chemistry has a prerequisite.
Okay.
The prerequisite for this course is Chem 101, which means you must have done that. In Chem
Okay.
101, you looked at the S block elements. That is the elements in group 1 and group 2, which are also called the alkali elements and the alkali earth elements. I also expected that you have also looked at the periodic table and periodicity, that is the property of the elements in the periodic table. Now, in this very particular class, we'll be looking at the P block elements. The P block elements are located in the periodic table in group 14, 15, 16, and 17. I'm sure you will want to ask, why P block elements? They are called P block elements because there is filling in of electrons into the P orbital. And that's why the name P block elements. Now, in the P block elements, which I said earlier, they are found in group 14, 15, 16, and 17. If you are using a long periodic table. But in another periodic table, you see them grouped as group 4, group 5, and group 6. Now, for this very particular class today, we are going to be looking at group 4 or group 14. Group 4 or group 14 are the carbon group. In this group, you have these elements: carbon, silicon, germanium, tin, and lead. Now, another notable thing that can be observed in this group is that there is a transition from metallic character to non-metallic character, because the group 4 elements are at the middle of the periodic table. So the tendency is that a lot of them will be metalloidal. Metalloid is an element that can exhibit both the properties of metals and non-metals. So they are found in between. Under some circumstances, they can act as metals. Under certain circumstances, they can act as non-metals. Now, what is this circumstance? If carbon is able to bond with a more electronegative element, carbon here will be playing the role of a metal. Now, if there is an element that is more electropositive than carbon, at that stage, carbon will be playing the role of a non-metal. Are you with me?
Yes, sir.
Now, like we said earlier, carbon and silicon are mostly non-metals. Germanium is a metalloid, while tin and lead are weakly electropositive metals. Now, carbon. Carbon is the first member of the group. Being the first member, because I'm sure when we are looking at periodicity, we must have been told that the size of elements increases as you go down the group. And electropositivity also increases as you go down the group. Now, being the smallest, it exhibits some anomaly, or what we call in inorganic chemistry, anomalous behavior. It has an abnormal behavior if compared with other members of the group. Now, tin or carbon itself has two allotropes. That means that carbon can exist in two different forms. One as graphite,
Graphite,
two as diamond.
diamond.
Now, graphite can conduct electricity. Why? Because it has loose electrons that moves around the atom. But diamond, because of its hard nature, has restricted movement of electrons. It cannot be able to conduct electricity. Now, if we look at tin and lead, tin and lead form amphoteric oxides. Now, what is amphoterism? I'm sure that should be the question that is coming up in your minds.
Yes.
Amphoterism is the ability to exist both as an acid and also as a base, depending on the condition in which it finds itself. It can exhibit the properties of an acid, and if it finds itself in another different condition, it can exhibit the properties of a base. Their chlorides are also volatile. That means if left exposed, they can easily go into air. For this course, this night, there are major objectives we'll be looking at in group 4. Occurrence, extraction, and the uses of carbon and its family. We're looking at allotropy, that is the existence of carbon in different forms, or the existence of the elements in different forms. We'll be able to compare their properties and examine or explain what is catenation. Now, occurrence. Carbon as an element is found in nature and in all living things. All living things contains carbon, and it can be able to bind with so many other atoms, especially hydrogen. And that's why sometimes we have a branch of chemistry that is dedicated to carbon and its compound, and that's what we call organic chemistry. Organic chemistry deals purely with carbon and linked up with other elements, particularly hydrogen and carbon itself and carbon with other metals. Silicon is present in rocks and also in some minerals, most especially like silicates or aluminosilicates. These are where you can also find carbon. If you pick sand, sand is mostly made of silicates. Rocks, silicon is found in rocks. So silicon and germanium are very important, and they can be used as semiconductors or also as transistors. You use them as semiconductors or in transistors. Like I said earlier, carbon can exist in its elemental state, like diamond or graphite. Diamond and graphite are two allotropes of carbon. Allotropy, actually, like I said before, is the ability of an element to exist in two different forms. Their chemical properties are the same, and mostly their physical properties are also the same. but they exist in two different forms. So we can have carbon diamond, we can have carbon graphite. In combined state, you can also find carbon. Like I said earlier, it's mostly found in living things. And the study of carbon compound is what we call organic chemistry.
Chemistry.
The air we have that we breathe contain about 0.03% of carbon. Coal and petroleum are mostly carbon. While silicon is the second most abundant element in the universe. You find it all over, particularly when you carry out study of rocks, study of sand, study of clay, and
And
study of most of these things. Sand is the major component of silica. If you talk about clay, then you have aluminum silicates that are the major component of clay. Glass is also a mixture of silicates. Glass is a mixture of silicates, which is mostly comprising of silicon. Germanium can occur in rare traces, like in coal. You can find it in coal, but it is in traces that you'll get it in coal. Now, if we try to look at allotropy, what is allotropy? Is one of the commonest questions that you can be asked. There are some of those terminologies I use that a lot of you have to take note of those terminologies because they are common questions, like anomalous behavior of an element, particularly the first member of the group. So allotropy is one of those questions that can be common. What is allotropy? Allotropy is when elements occur in more than one form. That is what you call their allotropes. And the phenomena of occurring in more than one form is what you call allotropy. Now, let me get to uses. Carbon carbon as diamond is used mostly in jewelries. And due to the hard nature of diamond, diamond can be used for industrial purposes, either in form of grit or for drilling or for grinding or for polishing of tools. Because of its hard nature and hard surface, it can be used for these purposes because it cannot break easily, it cannot be bent easily. That's why sometimes they employ the use of diamond for these kind of things. Now, silicon and germanium are used as semiconductors in transistors. Diamond does not conduct electricity, like I said earlier. And
yes.
why? One, because it is hard. Two, because of the tetrahedral arrangement of the atoms in diamond. Three, it does not have layer structures. And four, it has no delocalized electrons. For that reason, it cannot be able to conduct electricity. Whereas graphite can, because the arrangement of graphite is in layers. I hope by next week, I'm going to have a slide which I will refer you people to see that slides. In that PowerPoint, there will be slides that contain the structure of diamond and the structure of graphite,
Perfect.
which I hope also if you go through your books, if you have this my course content, or you take books like J.D. Lee, Inorganic Chemistry by J.D. Lee, you'll see all these structures found in there. Now, most of these elements in group 4 exist either as +2 oxidation state or they exist as +4 oxidation state.
Oxidation state.
Hence, because of that, they can be able to form multiple bonding within themselves or with other elements like nitrogen because of this oxidation state. Secondly, it can also form carbides. Carbon can be able to combine with elements that have close value of electronegativity. And because they have close value of electronegativity, they can form carbides like calcium carbide. I'm sure you know calcium carbide, which that is what we use in welding. You have the carbide. If you add water to it, it's going to produce ethylene, acetylene. Acetylene is the gas that is actually used in welding. So what welders do is that they go and buy the carbide, which is a solid substance, put it inside the cylinder, add water to it, and cork it and close it tightly. Now, because of the reaction there, acetylene gas is being produced. What the welder does is just to release the valve. The moment he presses the valve, the acetylene comes out to hit whatever metal surface that it has so that they can use it for welding. So it forms carbide. Another thing we must take note of is about their ability to catenate. Catenation is the ability to form long chain, for carbon to form long chain with itself, or by forming single or multiple bonds with itself. That is possible because of the similarity of the energy in which it has. It can form long chain of carbon single bond. It can form long chain of carbon double bonds. It can form long chain of carbon triple bonds. And it can also form long chain of carbon bonds with other elements. Now, when that happens, that is what you call catenation. It's another common question in inorganic chemistry. You all want to ask you a question. What do you understand by catenation? Or why do carbon catenate? Why do carbon catenate? So you should be able to have the answers to most of these things. I would want to pause here. I don't know, Fatima Ojo, you have any question you
Yes,
want
sir.
to ask me?
Yes, sir.
Yes.
Um, Actually, there is no question for now.
Yes.
Not sure. I don't have any questions, sir.
Okay, you don't have any question. Now, I will want to
Yes, sir.
give you an assignment that as you go back at home,
Okay.
try to look at why do carbon catenate?
Fascinating. Okay.
Why do carbon catenate? Because they are going to give you all the properties and the reason why carbon is able to catenate.
Fascinating.
So
Okay, sir.
once more for this very particular class, and I think you are the only one that is there. I try to
Yes.
hold the class because it is a recorded class. Those who are not in the
Okay.
class can still get back to it and read it in my learning environment site. So
Okay.
we will be stopping here. I don't know why the attendance was poor. Probably because the notice came very late. I think I posted the
Very.
notice just day. Is it yesterday or day before yesterday? When I
I
put,
think I just saw it today, sir.
oh, it's today you saw it. But I think it was yesterday.
Yes, I saw it today.
It was yesterday I tried to put the message across for the class. For that of the next class, I'm going to put it very,
Okay.
very early. So I'm sure by then a lot of you will be able to turn up for the class. And I have not been able to also post
Okay.
the lecture material in the learning environment. Before the next class, I will also be able to, I will also do that. I will post this very particular
Okay, sir.
lecture um, content in the learning environment so that on your own, you'll be able to have access to it and read it. And the other thing I'm suggesting to you also is to get this book by Inorganic Chemistry by J.D. Lee is very, very
Readily.
important. J.D.
Okay,
Lee.
sir.
There is
Jed.
also Cotton and Wilkinson. Cotton and Wilkinson can be very, very bulky, and it's discouraging sometimes to go through. But J.D. Lee is a summary. If you can get
Okay.
Inorganic Chemistry by J.D. Lee, it will give you a lot of informations of some of these things that I'm talking about. So once more, you are welcome. I
Okay,
hope we
sir.
are
Thank
going
you,
to
sir.
meet in the next class. So thank you very much.
Yes, sir.
Good night.
Thank you, sir.
Yeah,
Thank you, sir.
yeah, thank you.
Good night, sir.
Thank you.